Hello students, welcome. In this particular problem we are going to learn how to use relative velocity and as well as law of conservation of linear momentum. Read the question. A 50 kg man is standing in a one end of the long boat, okay? He start running towards other end. When he reach other end, his velocity is given 2 meter per second. Note this, relative to boat is given. If the mass of the boat is 200 kg, final velocity of the boat they are asking. So we can understand that what is the final velocity of the boat with respect to ground they are asking actually. So neglect the friction between boat and water. So now here how we'll do this particular problem. So we'll just take a case like a small boat, okay. So man standing. So mass of the boat is given, that is 200 kg, okay, that is initially at rest. Note this point, initially at rest. Boy is standing in a one end, he is also at rest initially, which means that inertial velocity is 0, inertial momentum of the system is 0. When this fellow starts runs with velocity of man, okay, with respect to boat, that is given as 2 meter per second, right? So obviously what you can expect, so when a person here, man, is start moving towards right side, bat this boat will move in left side, right? So this we can expect. So if it is moving means what is the velocity with respect to ground we have to find out, okay. So now you just take this particular problem. So first what I have to take is that relative velocity. The relative velocity of the man with respect to boat is written as nothing but velocity of the man with respect to ground minus velocity of the boat with respect to ground. So what I need is that velocity of the boat, okay, but I can't get here. So so many variables are here. First I'll find out what is the velocity of the man with respect to ground is velocity of the man with respect to boat plus velocity of the man with respect to velocity of the boat with respect to ground, okay. So now what I have to find out is that here you just see that both system, like man and boat, both are one system, okay. No external forces acting here, so which means that no external forces acting, so momentum is conserved. Upon momentum conserved means the inertial momentum is equal, total momentum is equal to final total momentum, right? So here for the system, so initially both are at rest 0. So now what happened is that boat is one object, man is another object. So what is a boat? So that is 200 is a mass, momentum, mass into velocity. So velocity of the boat with respect to ground plus. Now what I have is that man. So what is the mass of the man? 50. What is the velocity of the man? It is, we found by using relative velocity, right? That is nothing but velocity of the man with respect to boat plus velocity of the boat, okay. So just rearrange this, find out what is the velocity of the boat with respect to ground. So next is 200 velocity of the boat plus, just multiply inside. If you're multiplying inside, 50 velocity of the man with respect to boat plus 50 velocity of the boat. So I think data is given 2 meter per second. What is the velocity of the man with respect to boat? So then obviously what I'll have here is, here 50 into 2, this will become 100, right? So this will become 100. Next step, 200 velocity of, this is 0, okay, velocity of the boat plus 100 plus 50. If I add this to, it will become, I'll skip, I'm writing so many steps, so I'll rewrite this as 250, right? So 250. Now what I need is that VB. So next step is 250, velocity of the boat is minus 100, velocity of the boat with respect to ground is minus 100 by 250 meter per second, or minus, how can I write this, 2 by 5 meter per second. So note this point, minus shows that the boat is moving left side, negative shows that clearly boat is moving left side, okay. That's why the minus appears, okay.